I'm Ross Mira, and tonight we'll be discussing public key infrastructures. Using a public key infrastructure removes the need for users to access the public key of other users. A public key infrastructure provides the public key encryption and digital signature services necessary to verify, enroll, and certify users of a secure application. A public key infrastructure includes the entire collection of technologies, protocols, and policies that maintain, distribute, create, and validate public keys and their associated information. The public key infrastructure serves as a trusted third party in a secure transaction. The infrastructure is composed of a certificate authority, a key directory, and applicable management rules. The certificate authority functions as a means to verify and register the identity of users. It performs this function via a registration authority, which provides each user with a digital certificate that is maintained via the certificate authority. A digital certificate is a public document that contains information that identifies a user, identifies their public key, and provides a period of time wherein the certificate is valid and other such information. Each digital certificate is unique to each individual user. Let's examine a public key infrastructure in practice. Users register with a certificate authority, each providing their public key information to the certificate authority. The certificate authority provides each user with a signed certificate containing the user's public key and the public key information of the certificate authority itself. The certificates are stored in a public directory. Upon sending a message encrypted with the sender's public key, the receiver queries the public directory to obtain the public key certificate of the sender. The receiver validates the sender's certificate's signature using the public key of the certificate authority and then decrypts the signed message with the public key contained within the sender's certificate. This method is beneficial in that despite a data medium that may be insecure, the digital signature assures the integrity and authenticity of the information. Issues arise as there are numerous certificate authorities. This creates difficulties to establish trust between the users of different certificate authorities. In the case where two certificate authorities certify two different users who communicate frequently, the certificate authorities might certify each other. In other words, the two certificate authorities may store each other's public keys in certificates signed by the certifying certificate authority. This concept is called cross-certification. In scenarios where there are large numbers of users and certificate authorities, it is more practical to arrange the certificate authorities into a structure of certificate services than to require every certificate authority to cross-certify every other certificate authority. Now, the overarching goal of public key initiatives is a global compendium of users who communicate utilizing the ITU X.509 certificates. Currently, there are a number of different types of standard certificates, including the X.509, simple public key infrastructure certificates, pretty good privacy certificates, and attribute certificates. Each of these certificates has a separate and unique format, however. And the standard use in most environments is the ITU X.509 digital certification. The problem with it currently is that it is not fully standardized. Different companies implement X.509 differently. The outcome has been that the X.509 certificate generated by Microsoft may not be readable by specific browsers. The outcome has been that Next.509 certificate generated by Microsoft may not be readable by different browsers. Well, that about closes the book on public key infrastructures.